When we work with numbers that come from the real world, such as measurements with a ruler, the numbers are not exact, but carry some amount of inaccuracy with them. Because, for example, no ruler is perfectly straight. An important feature of experimental data is that the errors combine and propagate through calculations to produce errors in the calculated results. The concept of significant figures is a crude and inadequate tool for dealing with this, but for this course it does its job. Significant figures provide some different rules for science than what you are introduced to in your math class. The key to using significant figures is to be sure that you maintain the same level of precision throughout the calculation. In mathematics, you keep all the numbers from your results, while in science work, you frequently round based on the measurements involved. Let's take a look at our example here. How much heat would 5.0 grams of water absorb to increase the temperature 21.0 degrees Celsius? We have two measurements in this problem, 5.0 grams and 21.0 degrees Celsius. For 5.0 grams, the 0 in the 10th place is estimated. So this measurement could actually be 4.9 grams, 5.0 grams, or 5.1 grams. The temperature is also estimated to the 10th place. So the temperature can actually be 20.9 degrees Celsius, it could be 21.0 degrees Celsius, or it could be 21.1 degrees Celsius. Now, taking a look at solving this problem, we use the formula Q equals mc delta T. Okay, M stands for the mass in grams, C is the specific heat constant, and change in T is the change in temperature in Celsius. Q stands for the amount of joules. Okay, if we use this formula and we do all the possible permutations for all the possible mass and temperature change numbers, we come up with something like this. So in the upper left-hand corner, we're going to start with the 5.0 grams. And we're going to use that 5.0 grams and multiply it by the specific heat of water, which is 4.18 joules per gram degree Celsius, times the temperatures of 21.0, 21.9, and 21.1. Now, if we do that, we're going to get three different calculations with three different answers. Well, what if our mass was 4.9? We come over here to the right at 4.9 and we do the same calculation where we take the mass times the specific heat of water times the three different temperatures of 21.0, 20.9, and 21.1. And notice that we get three different answers in the three different possible permutations using the mass of 4.9. Now down on the left bottom, what if the mass is 5.1? Well, we have to do three more calculations then, and we're going to take the mass of 5.1 times the specific heat of water times the three temperatures, 21.0 times 20.9 times 21.1. And you'll notice that you get three different answers. As you can see in all the permutations, they all produce answers in which the first digit agrees. Now, what does that mean? Okay, the first digit is a 4 for 400 in all the answers. So we know with certainty that the answer is at least 400. Now, after the first digit, the uncertainty begins with the second digit, so that the answers here are different in the tens place. Okay, we have 3, 3, 4, 4, 4, 4, 3, 2, 3. So according to the rules of sig figs, we should be showing all the digits that are known with certainty plus one estimated digit. So we know with certainty the 400 part of the answer and must estimate the tens place. So let's go through our permutations and estimate all the tens place. So up here we get 440, then we get 440, and we have 440. Down here this is 450, and then this equals 450. This equals 450. Over here this equals 430. This equals 430, and this equals 430. So if I was to take the average of 440 times 3 plus 450 times 3 plus 430 times 3, the average of these answers would be 440 joules, where the 4 is known with certainty and the 4 in the tens place is estimated. Now, when I have to do calculations in science, I certainly do not want to have to do all these permutations. So in order to make it easier on us, we use the rules for significant figures. In order to reflect the true uncertainty of calculations within a measurement, the number of sig figs in the answers should be determined according to the specific rules that we're going to talk about in this section. First, it would be helpful to review the rules for rounding off answers achieved through calculations in the science class. Now let's take a look at the headings. Now I want you to remember that other sources may use a different method of rounding, but for our purposes, we're going to follow these rules. Okay, in the left-hand column, it says, if the digit immediately to the right of the last significant digit you want to retain is, and the heading for the column on the right says, examples of measurements rounded off to 3 significant figures. Okay, let's look at the first rule. If we want 3 significant figures in our answer, the last digit you want to retain is greater than 5, then increase the significant digit by 1. Now remember, we're all going to look to the 1 digit to the right of the last digit we're looking to retain. So if I take 42.68 grams and I want to round this to 3 sig figs, I'm going to count 1, 2, 3 sig figs. I'm going to look behind or to the right of that last digit. It's 8. 8 is greater than 5, so I'm going to increase the 6 by 1 and get 42.7 grams. Now, if the last digit to the right is less than 5, then the significant digit remains the same. For example, if we have 17.32 meters, and I want to round that to 3 sig figs, I'm going to count 1, 2, 3. I'm going to look immediately to the right. It's a 2. That's less than 5. So I'll leave the 3 alone and write 17.3 meters as my answer. Now, the problem comes into play when there's a 5 to the right of that last digit you want to retain. Okay, so let's talk about this circumstance. If there's a 5 followed by any non-zero digit, then the significant figure is increased by 1. So let's look at 87.2500007 grams. Now I want 3 sig figs. So we're going to start here on the left. 1, 2, 3. And I'm look immediately behind and there's a 5. Now, when you see that 5, it's a flag. Look behind the 5. Anywhere behind the 5, if there's a non-zero digit, you automatically increase that last digit by 1. So we're going to make this 87.3 grams. Now, if it's a 5 followed by only zeros, then the significant digit should always be an even digit. If it's already an even digit, then it stays the same. If it's an odd digit, then it's increased by 1. Okay, here's an example. Okay, 279.55 meters. Let's change that for a minute. Let's make that 79. Okay, 79.55 meters. And we were on a round to 3 sig figs. So we're going to count. 1, 2, 3. Look behind. Now, when I look behind, I see that 5. And the only thing that's behind that 5 is zeros. So I'm going to look at this digit right here. Okay, the last sig fig needs to be even. It's a 5. 5 is not even, so I'm going to increase that by 1 and say 79.6 meters. All right, let's take a look at this one. 0.04 165 kilograms. All right, so we want 3 sig figs. So we're going to, these zeros to the left are not significant digits. So we're going to start with the 4. 1, 2, 3. Okay, we look behind and there's a 5. And there's only zeros that are following that 5. So this 6 is already an even digit. Since it's an even digit, we're going to leave it alone. And we're going to round the answer off to 0.0416 kilograms. Now let's move on to the rules for rounding. For addition or subtraction, the result should be rounded off so that the final significant digit is in the same place as the leftmost uncertain digits for the measurement. Okay, let's do an example here. Okay, let's take 213.67 centimeters and let's subtract 98 centimeters. Now, when we do this on our calculator, we're going to come up with a math or a calculator answer of 115.67 centimeters. So this is my math answer. It's not my science answer, it's my math answer. Okay, so let's go up here to our measurements and look where the estimated place value is. Okay, the 7 is the estimated place value for 213.67. That is in the 100th place. For 98, the 8 is the estimated place value. So my answer must reflect the uncertainty of the place value closest to the left, which would be the 8. Okay, so I have to have my answer rounded off to the ones place. So if I look, it's a 5 in the ones place. Look behind, it's a 6. That's greater than 5. So I'm going to round off my answer to 116 centimeters. Okay, let's look at another example. Let's take 2.43 milliliters, and we're going to add 2.015 milliliters. And we get a math answer of 8.445 milliliters. Now remember, that's your math answer. It's not your science answer. Okay? So I'm going to look up at my measurements. 6.43, the 3 is the estimated digit. 2.015, the 5 is the estimated digit. So the leftmost uncertainty would be the 3 that's in the 100th place. So I want my answer to be in the 100th place. Okay? I look here, it's a 5, and that should be a flag for you. 5 with only zeros behind, and that becomes 8.4, and 4 is already an even digit, so we're going to leave it alone. So it's 8.44 milliliters as our science answer. Okay, let's move on to our next rule. In multiplication and division, the results should be rounded off to the same number of significant digits as the measurement with the fewest number of significant digits. So let's look at our example. Let's take 12.0 centimeters, and we're going to multiply it by 4.3 centimeters, and we get a math answer of 51.6 centimeters squared. 12.0 centimeters contains 3 sig figs. 4.3 contains 2 sig figs, which is the fewest number of sig figs in my measurements. So my answer should only have 2 sig figs. Starting on the left, 1, 2, look behind, it's a 6. That means I'm going to round this up to 52 centimeters squared so that my answer has 2 sig figs. Okay, let's try another one. Okay, let's do 2.50 grams divided by 0.04 centimeters cubed. So this is like a density problem. And my math answer comes out to be 62.5 grams per cubic centimeter. Now that's your math answer, it's not your science answer. So I come over here to 2.50. 2.50 has 3 sig figs. And 0.04 has 1 sig fig. So my answer can't have any more significant digits than 1. So I start on the left and I count 1. Look behind, it's a 2. So we're going to leave that 6 alone, and my science answer will be 60 grams per cubic centimeter. The next rule pertains to exact numbers. Exact numbers do not limit the number of digits in the answer to a calculation, so make sure that the answer reflects the uncertainty of the original measurement. Exact numbers actually are considered to have an infinite number of sig figs. Okay, let's take a look. For example, 1.569 times 12 equals 18.828 centimeters. Now this is kind of like addition. Okay, 1.569 added 12 times. So it's kind of following the addition rule as well. So if we take a look, my answer has 3 decimal places. So when I add, I want my answer to have the same number of decimal places as the original measurement had. So my answer should have 3 decimal places, and my math answer is also my science answer. Okay, let's look at a different example and do a little bit of division. Okay, 15.8200 grams divided by the number 7, okay, equals, okay, and my calculator comes up and displays 2.26 grams. Okay, that's my math answer. Now let me look at my measurement. My measurement actually has 1, 2, 3, 4 decimal places. So my answer should have 4 decimal places. And how I get 4 decimal places is by adding zeros, and those zeros become significant. So it's going to be 2.2600 grams. And that would be my science answer. Finally, if we are using conversion factors, such as 1 foot equals 12 inches is a conversion factor, or 7 days equals 1 week is a conversion factor, or you can say that like 1 meter is 100 centimeters. Now those are all considered to have no uncertainty because they are the result of definitions, not measurements. Therefore, the resulting answer should contain the same number of significant figures as the measurements. So let's take a look at an example. If we take 7,866 centimeters and we want to convert that to meters, okay, we're going to multiply by a factor that 1 meter is 100 centimeters. The unit centimeter cancels with centimeter, and we're left with 78.66 meters. Now let's look at my measurement had 4 sig figs, therefore my answer should have 4 sig figs. If I'm taking a look at something like 2.46 feet, and I want to know how many inches that is, I'm going to multiply by 12 inches in a foot. Okay, the unit foot cancels, and you get a math answer of 29.52 inches. Now, let's me count. I have 3 significant digits in my measurement, so I better keep 3 significant digits in my answer. Now, it has 4 right now, so I'm going to round that to 29.5 inches. The end.